Welcome everybody to DynamicsCon, and thank you for voting this session. I'm Stefano Demiliani. I'm a Microsoft MVP on business applications, and in this session we'll talk about Azure Functions for Dynamics 365 Business Central developers. We'll see how to use Azure Functions at best with your Dynamics 365 Business Central tenant in the cloud. My main expertise is Business Central, but I'm working a lot on cloud applications. So I hoping that this lesson will be helpful for you. And here you can find my reference if you need more. The agenda for today's session is why you should use Azure Function for Dynamics 365 Business Central. We'll see a brief overview of the Azure Function platform, and we'll see in depth how the platform is composed. We see how to create Azure Functions with the available tools that Azure now offers. And after that, we see how to use Azure Functions with IR language, so inside our Business Central extensions. And at the end, we'll see a lot of tips for using Azure Function in real world, so in production environments. I think that this is the part that you should master more, because it's handling Azure Function in production is something that is different than Azure Function in a testing environment. So this is the planned agenda for this session. We have Dynamics 365 Business Central today. I think that everyone that is listening to this session knows what Dynamics Business Central is today. It's an ERP, it's a cloud-based, and Dynamics Business Central, it relies on Azure, the Azure platform, and it relies on the Azure SQL Elastic Pools as a backend. So Business Central is an ERP in the cloud, is a SaaS application, and every SaaS applications, you cannot directly modify the underlying platform. So you cannot execute custom code in the platform. You cannot install custom code inside the platform. You cannot directly interact with the Azure SQL underlying platform. But for you, Business Central is a service. So when we talk about SaaS, software as a service, we need to talk about serverless. So serverless means that we need to talk about applications that need to be created in the cloud, deployed in the cloud, and executed in the cloud. You cannot think to use Business Central SaaS as a standard on-premise platform, so where you can install software or something like that. You need to start thinking about serverless. Serverless means one of the main building blocks about serverless is Azure Functions. And so why you should use Azure Function with Dynamics Business Central, why we are here today? Because Azure Functions are a fundamental building blocks of serverless applications. And Azure Function with Business Central is extremely useful for a set of tasks. One task, for example, is executing custom code in a cloud environment. If you want to execute custom code, you need to create an Azure Function, because you have no way in the cloud to execute custom code, custom external code, I mean. Azure Function is the only way available for executing .NET in a SaaS environment, like .NET variables that you will use in the past with NIV or with Dynamics Business Central on-premise. If you want to reuse .NET variables in the SaaS, you need to create Azure Functions and embed them inside Azure Functions. Azure Functions are useful with Business Central if you want to reuse existing libraries. If you have, for example, today existing library like DLLs that you are using on-premise, and you want to reuse that library in a SaaS environment, you cannot install that in the SaaS environment, but you need to embed them inside an Azure Function. Azure Functions are also useful if you need to interact with Azure services, all the Azure ecosystem. And in a cloud environment, this is extremely important. You should not do all with Business Central, but you should start seeing as Business Central as a part of a big ecosystem in the cloud. Azure Functions are extremely important also for integrating Business Central in the cloud with external applications. And last big process is if you want to create big processing, like workflows, like timer triggers, timer-based execution, or something like that. So processes that runs in the cloud, Azure Functions are a fundamental building block for doing that. So these are the main reasons why today we need to start embracing Azure Functions with Dynamics Business Central. Azure Functions gives us a totally embedded experience for creating, deploying, and managing our functions our code in the cloud. Azure Function starts with triggers. Trigger means an event that is an input for our Azure Function that starts our Azure Functions. Events can be of different types. We see that later. Azure Function has input parameters, so what is called bindings. Azure Function has input parameters. You can then develop your code in the browser directly inside the Azure portal. This is not what I recommend, but you can do that. Or you can better experience, develop your Azure Function locally, so inside your Visual Studio or Visual Studio Code or other tools inside your local machines. And only when tested, you can deploy the functions in the cloud. The function is executed in the cloud in a service called App Service. The function has automatically monitoring experience in the cloud. You can monitor and track all what happens in your functions directly from the Azure portal. And then the functions obviously can have output. Output are the results of your function. That can be simple result or actions that you can do inside other services in the cloud. What is important to know is that Azure Functions is for you as a totally transparent application and totally transparent ecosystem. So the platform, you don't need to manage the underlying platform. Your focus is on the business logic. Your focus is on the code. The platform, the scalability, the security, and so on is all managed by Azure automatically. Azure Functions can be developed in the cloud with your tools that you want, Visual Studio or something like that, and can be developed with different languages. You can develop Azure Functions with C#, you can develop Azure Functions with JavaScript, with PHP, with the PowerShell, Java, TypeScript, and something like that. So you can select your preferred language for developing Azure Functions. Common question is, can I develop Azure Functions directly in IL language? The answer is no. You can use Azure Function from IL, and we'll see that later, but you cannot develop Azure Function directly in IL language. The Azure Function architecture. The Azure Functions is a service deployed in the cloud. Azure Function relays on App Service, the bottom layer. The App Service is a fully managed web hosting service for building web applications, mobile backends, or RESTful APIs, and it's fully managed because it's managed directly on Azure. An Azure Function has triggers. Trigger means what causes an Azure Function to run. A trigger defines how a function is invoked and how a function must, and a functions normally must have exactly one trigger, because a function can be triggered only by one event. Triggers can have associated data that normally are provided as a payload of the function. Then there are bindings, input and output bindings. The binding normally is a connection to data within your function. Bindings are optional. They can come in a format of input and output. An input binding normally is the data that your function receives, so your input parameters. And the output binding is the data that your function sends to the outside as an output. Unlike triggers, a function can have multiple input bindings and output bindings. Then, defining that's the function runtime. The function runtime is the engine of your Azure Functions, what executes your code deploying in the cloud. And after the function runtime, there's the function programming interface Functions running interface means that your Azure Function expose endpoints and expose endpoints that you can call from external application, endpoints that are secured and managed by Azure and scaled by the Azure App Service. So this is the big overview of the Azure Function architecture under the hood. Azure Function templates. Azure Function provides templates that you can use as a starting point for building your functions. Templates are of different types. I think that the most useful templates for our as a Business Central developer is what is called the HTTP trigger. The HTTP trigger is a function that is executing in the cloud and like sending an HTTP request to an endpoint. So HTTP request like get, put, and so on, and you have a response. It's the most useful trigger, I think, in the for Azure Functions. Then there are other types of triggers and so templates. The timer trigger templates is quite useful. For example, if you want to execute predefined code on a predefined schedule. So, for example, if you want to create tasks that are executed on a timer schedule. Then there are other types of triggers that I don't want to go in depth today, but are triggers that are binded directly to Azure resources. So, for example, blob triggers are triggers that permit you to start an Azure function while something happens inside a blob in an Azure storage. Inside, if you, for example, if you save a file in Azure storage, you want to trigger Azure functions. All the triggers linked to event grid or service bus or queue trigger are triggers that can permit you to start Azure function when a message arrives in a queue or in a service bus queue or in an event grid service. So you have a set of triggers that can start Azure functions from HTTP or directly from events that occurs on Azure resources. When you create an Azure function, you should select the trigger that most applies to you for your business scenarios. For example, this is the standard way, I think, when you start working with Azure Function with Business Central. You have Business Central, and that is deployed in the cloud in a SaaS tenant, and then you have the Azure platform. Normally, when you have an Azure Functions deployed on Azure, from Business Central, you send an HTTP request to the endpoint of the Azure Function. The Azure Function responds you to an HTTP response object, and with the result of the code deployed in the cloud, so the result of your function. And in AL, you should use a built-in data type for that is called HTTP client. The HTTP client provides a data type created for sending and receiving HTTP requests from a resource, and this resource must be identified by an URL. And this is the object that you should use for calling Azure Functions in the cloud. Saying that, we start seeing a brief demo on the Azure Functions. So first demo is how to create Azure Functions. For creating Azure Functions, you have you can use a set of tools. As said before, you can create them directly in the portal, but I don't recommend that because creating the portal is not a best experience. My suggestion is use Visual Studio Code. That is your favorite tool also for developing solutions with Business Central, or better, in my opinion, use Visual Studio, and we'll see both later. Now, I want to quickly show you how to create an Azure Function with Visual Studio Code. For creating an Azure Function with Visual Studio Code, you need to have the Azure extension and the Azure Function extension created that permits you to access all the Azure resources. First thing that you have to do is to sign in to your Azure subscription, that where you want to deploy the functions. And then you can create a new project by clicking here. You select a folder. I select this folder. And you select then a language for deploying your function. I select C#, for example. And then Visual Studio Code prompts you to select a template for your function. One of the list of the templates I've previously described in the previous slides. I select, for example, the HTTP trigger, that is a template for calling a function by sending an HTTP URL with an HTTP call. And I give a function name, for example, name. Then it's optional, but you can provide an namespace for your function. For example, I use this, and then you need to select what type of authentication you want to attribute to your function. For example, we'll see them later in details, but I select function here, and I open the project in the current window. As you can see, Visual Studio Code works, and then it prompts you with a project that contains your function code. This is a function that is a function is normally composed by a function app that can contain different functions inside that function app. So our function app is called HTTP trigger DynamicsCon. And our function is what is the core with this attribute function name, and this is the function name. I can change here my function 1, for example, and this is an HTTP trigger function. So this function can support get and post, but you can, if you don't want, for example, if this is a method that only retrieves data, you can remove the post, for example, and by removing this. And here, as you can see here, you have an authorization level where you can change. Here it's a function, but you can change that and, for example, set it as anonymous or something like that if you want to. Oops. I will talk about that later, but you can change that here. And the function, what does the function? It retrieves a parameters. This is the standard skeleton. It retrieves the parameters. It converts the parameter as a JSON. It performs the name. It retrieves the name parameter, and it responds you, okay, I name, or if you have passed a from parameter, it responds you with an error. Inside that, you can obviously remove all this code, and you can write here your custom code. You can then deploy when your function is created. You can then go here and click deploy to function app, and this deploy to function app takes this function and deploys it to the cloud directly without doing nothing. All is managed for you by the platform. So very easy, very quick to do that. To do a real world demo, I just close this. This is only for showing you how to create an Azure function with Visual Studio Code. My favorite tools is for creating Azure function is instead Visual Studio, because I think that Visual Studio is more smart for creating Azure function, has more features. In this demo, I have created a function for managing one of the most common requested tasks in the cloud, so managing files. As you know, Business Center is a cloud application. You cannot create and store files in a file system or handle files directly in the cloud. But you should, for that, if you want to save files in a location for your users, you should rely on Azure Functions that can save the files inside the Azure storage. And here I created exactly like two functions that permits a function app called SaaS File Management with two functions. One is called upload file and one is called download file. The upload file function retrieves is a function that can be called with post, only with post attributes. This post attribute receives a JSON object that contains the file name, the file type, and the file extension also I placed here, and the base 64 of the binary file that you want to save. So from Business Central, you pass a JSON object that contains these parameters and the basically for the content of the file. This function then calls a method called upload blob async, and this method is responsible. If I go on this method is responsible for pushing these files and saving this file into the blob storage. As you can see here, I used some libraries exposed by Azure that you cannot use directly from IL language. So, for example, here I'm using windows.azure.storage libraries that are the libraries of the .NET framework that permits you to work with the blob storage. And here I'm creating create a container or reference that if it exists, and then I uploading the file inside that container. The same fees is for the download files. The download function is another HTTP triggered function that supports posts, and the download function as a parameter, a JSON object parameter that wants to the file name that you want to retrieve from the blob storage and the URL of this blob storage, the file inside the blob storage. And this function calls the download blob async method, that is a custom method that returns, connects to the cloud storage, read the file in this way. It retrieves the file. This is the line that retrieves the file. It parses the file. It receives the content of the file, and then it retrieves the download. It downloads the byte array of the file to the client, the caller. So in our case, it's Business Central. When you upload this function to Azure, if I click here and I go on my Azure portal, this is my function deployed in the cloud. As you can see, this is a function app called SaaS File Management. And inside this function app, I have different functions. I have the upload file function, the download file function, and also here I have the list file function. I not show here, but here I have also a list file function that simply returns a list of the files that I have on my blob storage, because maybe I want them in Business Central, for example, to have the option to show to the user what files are saved in that storage. So a function app has different files, and each function has an URL that you can call. This is the URL that you can call, and the function app has some security inside that. You can create as anonymous, or you can create it with keys. And in this way, I'm creating with the authorization level as function. So it means that I need to pass a key to the caller must to pass the key to the URL of that function. And I talk about that later. To show how it works in Business Central, if I go, I go here before. I created an extension. In my extension, I created two actions inside the item list. One is for uploading a file. One is for downloading the file. This action simply calls methods defined in this code unit. The uploading file is asks for a file to the end user, retrieves the files, and then creates a JSON object in this way by passing the content of the file name, and the file type. And with the HTTP client object declared here, with the I call it a post method by passing the URL of the function and the content of the request to send to the function. So this is the JSON object. I'm passing a JSON object that contains the basic four element of the file name, the file type, and the file extension. These calls, if successfully performed, retrieves fills an HTTP response object. That is the response. And for example, you can read that response object to have the URL of the uploaded file in the cloud. The download file functions does exactly the same. It creates a JSON object with the URL of the function that or the file that I want to retrieve, the file name that I want to save locally, and the file type. It sends a post request to the function URL by calling the HTTP client.post methods, by passing this JSON object, the HTTP content, and reading the response. From the response here, I'm reading the base64. I'm reading it as a base64 element because, as said before, the download method, the download Azure function returns a base64 string, and in this way, I'm converting that into the file content, and I'm saving the file content to the end user. What happens here if I show here? If I upload the file, I select the upload, it prompts me to loading a file. I, for example, upload this file, and this file function works, and this file is loaded and uploaded to the cloud. We'll see them. If for example, I download this file, I download a file. The downloaded file that downloads a file name that I pass from IL. In this case, I'm downloading a file called DynamicsCon.txt. It's downloaded to the client, and if I open that file, you can see that if I open this file, the file content is displayed to us. So very easy to do a file. You can, with Azure Function, you can do a complete file management in the cloud. And if I go inside my storage account, just to show you, this is my storage account where the function works. This is called file storage. Inside my storage account, I have a container of files. I'm working on this container. And as you can see, I'm downloading this file, and I've uploaded this file. So you can do that easily. A file completely file management in the cloud. Here I'm using the blob storage, but you can also use the file storage, Azure File Storage. That you can, Azure File Storage is a completely file storage in the cloud that permits you also to the end user to map as a local drive, and then you can create folders and something like that. So very, very easy for your end user. We go a step later. Azure Function permits also to holding configuration, so all your configuration parameters. Configuration parameters inside Azure Function are handled with normally with a file-based local.settings.json file when you debug the Azure Function. When you deploy the Azure Function in the cloud, these settings are deployed in the cloud inside the Azure Web App settings, and you can directly manage these settings inside the cloud, the Azure portal. And you can also store secrets inside the configuration files inside the Azure Web App settings. But for secrets, the recommendation is use Azure Key Vault, because it's a service created for storing secrets, and it's much better and much more secure. We talk about later, before we talk, when we create Azure Function, we have talked about authorization. We saw that when you create an Azure Function, you need to select an authorization level. And when you create the Azure Function decoration, it's you can see the authorization level as one of the parameters of the Azure Function main methods. And anonymous obviously means that no authentication is required, so everyone can call this endpoint. In a real world, I think that you don't want this. So as a standard, Azure Function has a key-based authorization mechanism, and you can inside your Azure Function, you can click on Manage, and here you have a key definition area where you can create function keys, admin keys, or system keys. There are two types of keys normally. What is called host keys and what is called function keys. Host keys are function that are keys that work at the app level, so the highest level, while function keys are keys that are work at the function level. So we saw before that we have an app, function app that can contain different functions. And if you are using function keys, you need to provide to your clients a key for every function. If instead you use host keys, you need to provide a single key for all the function inside that function app. There is also a special key called master key. The master key is always present. You cannot remove that. You can only renew that. The authorization levels. When you call, if you are not using anonymous, that is what I recommend. You need to call an Azure function with the endpoint by passing the key. The key can be passed directly in the URL. So like in this way, code equals and the key. Or you can pass the key inside an HTTP header parameters that is called X functions keys. If you don't want to use that inside URL, you need to place in your IAL code an HTTP header parameters in your HTTP client call X function key. And obviously you need to pass only the key value, not the key name. Function. If you select function as authorization level, you need to provide the key, and function is the lowest level. So if you select function, you can provide function key or host key. It depends. It works both. But you select admin as authorization level, you require to provide the host key, so the top level key. Otherwise, you have an error, unauthorized. If you have selected the system authorization level, I don't recommend to use system, but if you select that, you need to provide what is called the master key. Otherwise, the other key will never work. So just remember that. And if you want more security, you can also use Azure AD authentication for functions, so Azure Active Directory. And you can simply enable that by going to platform features, clicking on authentication and authorization, the authorization sections, and then you need to turn on the app service authentication by clicking the link, and select login with Azure Active Directory, and then select your authentication provider. That can be Azure Active Directory or some provider like Microsoft, like Facebook or Google or something like that. This is a more advanced mechanism. And obviously, if you select Azure Active Directory, you need to create a new Azure Active Directory app registration, and you need to retrieve a token and pass that token to your function calls. When you create a function, you normally have a function app that can contain multiple functions. We saw that just before. You need to remember that a function is a part of a serverless architecture, and normally in the cloud, errors can occur, and so components can fail. So one of the recommendation is to minimize the impacts of problems in the cloud. The recommendation is split your function into multiple function apps. Don't create one function apps with 10, 20 or more function inside that, but split this function into multiple function apps and as them independently. For example, in this way, if you have functions that work on customer products and orders, don't create a single function app with all, but separate your function app into different endpoints, and this is much better for a cloud environment. Another topics that I want to leave here is normally when you have function app and these functions uses the same services. Imagine that you have a different function that goes to an external system like a CRM systems for retrieving orders, for retrieving items, for retrieving purchase orders and something like that. So every function app needs to connect to the external CRM. Normally, what I see is that every developer does a scenario like this, where the function app, the function one create an instance of service 1, service 2, and service 3. So different connection to the same service, but it's much better to have instead of having different functions that connect to the same service. So instead of having function 1 that connect to service 1, 2, 3, and function n that connect to service 1, 2, 3 again, it's much better to create one single instance to service 1, 2, 3, and then having function up and function n to connect to this single instance. This is called dependency injection. You can do that while using this library, microsoft.azure.function.extensions, and it permits you to save time. You remember that in the cloud you pay for time and you pay for memory. These tricks permits you to save time and memory, so a lower cost of your functions. And I provided here a complete example of how to use Azure Function Dependency Injection for connecting to external services in this link. Another recommendation is to avoid long-running functions. Remember that you have a timeout from the platform for Azure Function too. So if you have a consumption plan where you pay for consumption, the default timeout is 5 minutes, and the maximum is 10 minutes. This timeout is higher with the premium and so on. But remember to handle that. So the timeout is normally defined in the function timeout property in the host.json file. Remember that the HTTP trigger, regardless of the function up timeout, the timeout is always maximum is always 230 seconds. So you need to handle that. And timeout is not only the duration of the call, but also is affected also by importing dependencies or something like that. So whenever possible, it's better to split your function into a set of functions. Another tricks that you can use is deployment slots. Deployment slots are using for testing your function. So when you create a function, normally this function is deployed directly in production. But maybe you don't want that because you are working on a new release of your function. And you can simply go on the portal, create a new slot by clicking on slots, give it a name, for example, testing, and then deploy your new version of the function to the testing endpoint and not to the production. In this way, you can have some users that are working on the testing endpoint. When you are ready, you can simply go on the testing endpoint and click on the swap button. The swap button means that the testing now in this moment becomes the production endpoint, and all is managed by you transparently. You don't want to try nothing. And there's a link here that explains more in details how to do that. I recommend these tricks when you go in production. Another interesting recommendation I always recommend when using Azure Function is use telemetry. Azure Function has a default logging infrastructure built in. You can also plug that default logging infrastructure to a more advanced service like Azure Application Insights. Application Insights permits you to have dashboards and complete logging of what happens in your functions. You should always enable Application Insights along after inside your function. So inside your function code log, because it permits you to debug better your functions. And another extremely important, in my opinion, topics is that if you want to control better your function, who can access that, who can work on that, use Azure API management. This Azure API management is a service that enables you to publish, secure, and maintain endpoints, APIs. So instead of having customers that calls directly your Azure functions, so your Business Central tenant that calls your Azure functions, it's much more secure to have your Azure function, your Business Central that calls the Azure API management endpoint that in turn call your Azure functions. And just to a very, very quick demo for this, I provided here an API management instance called SD API. In this, if you create an API management instance in the cloud, you can simply go inside APIs and you can click Function App. Here you can select a function app to import. For example, I want to secure my previously created Azure function for handling files. I click on Select. Here it lists all my functions. You can select all, or you can, for example, avoid some other functions. I select all for the moment, and I click on Select. As you can see here, it gives you a base URL. So your function URL now is not the URL provided by the function, but is the URL provided by the API management. So it's a URL / name of the function. If you click on Create, your function is imported into Azure API management, and then you can manage a large set of parameters. For example, if I click on my API, you can, for example, create policies for inbound, for who can access your functions. You can, for example, apply IP filtering. You can create rate limits. You can create query parameters. You can set other parameters that are mandatory, and more advanced policies. This is a better way for using Azure Function in production, because it permits you a more complete security. And last thing that I want to show, if I want to my Azure Functions, I talked about before about logging. When you create an Azure function, you have a first set of log. But if you create, if you activate application insights, you can also see the application insights monitoring. And for example, you can see log inside failure request, response time. You can, for example, see the application map. The application map is useful if you have an Azure function that interacts with different Azure services. For example, I have an Azure function that interacts with my blob storage. You can see that that in this period of time that you can set here, I have received 4 calls. The duration is the access to the for storage is this, to the blob storage is this. You can see the client that has accessed this, that has sent the request, and so on. So you can check your performances. You can see like metrics, for example, that permits you to in real time show the incoming requests, the outgoing requests, and so on. You can also work on search, for example, for searching what happens on your functions, all the complete tracing. For example, here I can see that in this day that there's a request. You can see the complete trace of the request. You can see that I have a module, external module called dependency is loaded. So you can have a complete end-to-end monitoring of the function. Very powerful. I recommend to use that on every installation of the Azure function in the cloud. Last slide. What about pricing? Azure functions are not completely free. It's a service offered by Azure. You have you can choose for 2 types of main function levels, pricing levels. The first level is what is called the app service plan. The app service plan means that you pay for an instance. So you pay for a set of resources, for example, like a virtual machine. You pay for a set of resources, RAM, CPU, and so on. And you can deploy on that app service all the functions that you want. You don't pay for execution, but you pay for this set of resources reserved for you. The other plan is what is called the pay-as-you-go plan. Pay-as-you-go plan means that you pay for calls. Remember that the first million of requests and for requests is free each month. So you start paying after a big set of large set of requests, and then you pay above these limits. You pay for a mix of memory consumed and time used for your functions. So, for example, if your execution of your function requires this set of megabytes, and for 3 seconds, you pay for 0.384 gigabytes for seconds. And this must be multiplied for the execution time costs. That is normally $0.00016. So as you can see, a single execution of your function is a low fraction of euros or dollars. So the cost is very low for Azure Functions. 1 million is free. So I recommend to use Azure Function a lot in your cloud environments if you want to embrace completely the cloud and to want to have a better sustenance. In these 40 minutes, I hope to have give you an overview of the platform, how to use them from AL, and especially how to use them in production. I think that the most important part here is to understand tips and tricks for using them in productions. Feel free to do questions. Thank you for going to this section, hoping that your work with the Business Center in the cloud will be much more improved by using Azure Function. Thanks for watching, and join me in the conference chat if you have session, and thanks to DynamicsCon.